Hi there. This is Mr. Delovit, your physics teacher. Today we are going to continue looking at mathematics in ordinary level physics. So this is part 3, and today we'll be focusing on graph work. So graph work is so important in physics that if you don't know it, you're missing about 10 points in your exams. So it's one of those skills or competencies that you need to have at the end of your ordinary level studies or your junior secondary school before even going to high school. So what is a graph? That's a question. So a graph is a diagram, you have to understand, that shows oh sorry. It's a diagram that shows the relationship between two or more variables. Between two or more variables. But at this level, at the ordinary level, we'll be looking just at two variables. So when we look at two variables, it becomes a linear relationship. It becomes a linear relationship. And now these two variables can either be called x and you call what? Y. We call them x or we call them y. In physics, we call them x. This x and y are called variables. I call this minus a variable. All of this are called variables. We call them variables. And these variables are what we call physical quantities. Physical quantities. So our x can be represented by, our x can either be current, or x or y can either be current, force, acceleration, length, mass, etc. So we're talking about these x and y are variables and they are physical quantities. You can either have length, acceleration, mass, and so on. Right. Now, these variables, as we all know, these variables are, or we call them the x, we call them the x and y axis. So these two variables form two planes. We have the x plane, we have the lines we call vertical line, and we have the horizontal line. So we have the x axis, I have the y axis. Sorry, we have the y axis, I have the x axis. You have the y axis, I have the x axis. Now, this is a y plane and this is the x plane. So the both of them now joining together at this point, they form the x y plane. They form the xy plane. Now, if I have a value, a number, an x value, and I have a y value, these two, for example, if I have 1 here and I have 2 here, when they meet, when you draw them and they meet at a point here, this is what we call a point. A point is called a coordinate, which is made of x and y, or is made of 1 and 2. So the point here is 1, and the value here is 1. The value of x is 1, and the value of y is 2. So at this point x here is a value of 1 and 2 that has meet up or has joined together to form this point. So this 1 and 2 in these braces is what we call a coordinate. We call a coordinate, or we call a point That's what you're going to be using to plot. It's called a point. Yes. Now we are seeing that a graph is a diagram that shows relation to two more variables. I was saying these variables or variables can either be, they are called physical quantities, and it can either be force, acceleration, and so on. Now you're seeing that this, for us to plot a point on this, we need, on this y and x axis plane, we need 2 points. A point from the x, we need two values, a value from the x axis and a value from the y axis. So when these two values, this value from this x and y axis meet on this plane, this, the point that they meet is called a point, or you call a coordinate. I'll write in the form of braces like 1 and 2, like that. Now, how do we plot? So the main technicalities as a student in ordinary level, in form 3, form 4, form 5, or grade 8, 9, 10, the difference, what you need to know exactly is, first, what am I plotting? Where is the data? What information am I plotting the graph? Because before you plot, them will give you an information. You're plotting numbers. Which one is on the y-axis and which one is on the x-axis? Where are the points I need to plot? Where are the coordinates? That's what you need to be thinking about. You need to ask those questions first. And when you go further, you know that this y-axis is also known as, carries the dependent variable, and the x-axis carries the independent variable. And so what is different between a dependent and independent variable? The independent variable means that it is the one that does not change, that does not depend on the other. Dependent variable depends on the independent variable. For instance, if I'm a teacher and I said my class will be at 2 o'clock on Saturdays. Now you're going to school is dependent on the time that I have set for the class. If I set the class time of class at 9 a.m., you'll be going to school at 9 or 8 because I've set the class at 8. If I put a class at 2, you are going to school at 2 because that's where I've put the time. So the time you are going to school is depending on the time that I've put as a time for the class. So your time and in that situation is independent. And you are going to school is dependent. So you're going to school is y-axis. Why? The time that you have set for the class is put as what? The x-axis. So that's what I mean by dependent and independent. So, but at your level, you will never be asked whether to decide which one is dependent or if it's independent. Because in every question that you see at this level, they'll tell you, plot this graph with this value, this quantity on the x and this value on the y. They will tell you which one is the dependent and which one is the independent. But just know in your mind that when they talk about x-axis, the quantity that is here is the independent, and the quantity that is here is dependent. Just having in back of your mind, and this man is independent. So just having in back of your mind like that. Okay. Now, if you have this in back of your mind, then we can now look at what are the methods. How should I plot my graph? What should I do in plotting a graph? Because those are the skills you need. Let's look at the method. method. 1, you have to prepare your data. 2, you have to draw your axis. By the X and Y. 3, identify the quantity to be plotted. On the X and Y axis. And 4, label the axis on the graph. Number 5, after you've labeled, choose your scale. After you have chosen your scale, plot points. After you have plotted your points, next is you draw a straight line. After you have drawn your straight line, calculate the gradient. You can now, a straight line or curve, it can be a curve. It can be a curve. It can be a straight line or a curve, so it must not be a straight line. After you calculate the gradient, or now you calculate, find the significance of the curve or of the graph. You can find the significance of the graph or the straight line of the curve. Yeah. Also, questions can ask you to calculate the area under the graph. So you don't want this one, the questions that depend. So if you follow, we have to follow. We'll follow these steps to see how we can do some examples. Right. Okay. Good. So now, if you look at, so for us to now, the first thing, let's try to look at is particular data, and then see how we can be able to plot that data. Right. Okay. Let's look at that. Okay, if we have these data, for example, these are data that I want to plot. The data I want to plot. If you look at the data, this you have voltage against the unit, which is volt. You have current against the unit, which is what? Ampere. You have this value from 0 to 14, 0 0.02, 11.0. Now they're asking you to plot a graph of potential. Plot a graph of potential difference on the y-axis and a current that's n current I on the x-axis. That's what you want to plot. So it told you that, okay, now this v should be on what? The y-axis, and this band, the current, should be on the x-axis. So they told you already that you're told already. So you don't need to decide which one should be on the y and which one should be what? On the x, right? So the first thing is that we said is you need to prepare your data. Now, what do you mean by preparing data? Now, if you want to prepare your data, now let me give you what I mean by preparing your data. Okay, if you look at, for example, we have seen the data there. So in seeing this data there, I come and the data might be like this. If the data came out and you have something like this, and this is V, this V, and this is I, and it's like this. I have 6,000 here, 8,000, 9,000. We have 0 0.001, 0.002, 0.003, like something like that. Now to plot this data on your graph is difficult, so you have to always convert it to standard form. And if you don't know how to convert to standard form, watch the video on how I've part 2 of this video to see how we convert stuffs or convert numbers, whole numbers to standard form and decimal standard form. The first thing is that you have to transform this table to something like this. Okay, if I have this, now my V now, instead of having V here, I will not have that. I'll convert all of this to standard form. If I do that, I'll have 6 times 10 to the minus 3, 8 times 10 to the 3, and 9 times 10 to the power 3, because the decimal points has gone 1, 2, and 3. Now, when you do that, you see all of the numbers have 10 to 3, 10 to the 3, 10 to the power 3, 10 to the power 3. You cannot be writing all of that numbers here. It's very bulbous and it's not really looking nice. So I take this number, or one of this number, and I'll bring it here. And I put here with 10 to 3, and I put my V. Then I'll just put what 6, 8, and 9. Meaning that if I want to read this value here, how will I read it? It will be 6 times 10 to the 3 volt. How I read it. How will I read this one? It will be 8 times 10 to the 3 volt. How I read this one? 9 times 10 to the 3 volt. So you cannot say your answer is 9. The answer is 8 or 6. This one you're doing this just for you to make it easy for you to plot on a graph. Does not mean the value is 6, doesn't mean the value is 8, doesn't mean the value is 9. The value is 6 times 10 to the 3 volt. Whereas 8 times 10 to the 3 volt. Whereas 9 times 10 to the 3 volt. I hope it's understood. Okay, good. Now, the next is, instead of writing now A, I'll not write. I'll convert this one to standard form. So that will be, since it's going like this, it will be negative. Now you have 1.0 times 10 to the minus 3. You have 2 times 10 to the minus 3. 3 times 10 to the minus 3. So you have minus 3 all over. I'll bring it up here. Minus 3. A. Now you have now 1, 2, 3. Now in this case, you have prepared the data. It's easy for you now to plot. You can plot 6, 8, 9, 1, 2, 3, rather than plotting 6,000, 9,000, 8,000, or 0.01, 0.02. It's so difficult to plot that. And so that is how we are going to plot this, right? This is how we're going to prepare your data for plotting. That's what I mean by plotting. So you have to take note. These values, all these numbers must be the same before you carry and bring here. These ones must be the same before you bring it up here. So this means that all the values here carry the number 10 to 3. All the numbers here carry the number what? 10 to the minus what? Minus 3. So take note of that. Because if the values were 1 times 10 to the minus 3 and 2 times 10 to the minus 2, I cannot take and put here 10 to the minus 3 and put here, because this man has 10 to the minus 2. So for me to do that, I have to convert this, add, it will be 0.2 times 10 to the minus 3, no, 20, sorry, times 10 to the minus 3, before I can, means that instead of writing 1 here, I'll write 1, I'll then put 20 here, before you can clock that. So that's how it works. Right, okay, good. Now the next thing is choosing a scale. How, after you've done that, you have to label your axis. Yes, the next is labeling axis. After labeling your axis, so how do we label your axis? So you have to draw your axis first, like this. When you draw it, and then you have to do label. It'll be an x, this is my y, and this is my x. Now when you've done that, it can either be what? The force. You put a symbol of the quantity stroke the unit. Then this man will be, let me say, a, which is acceleration stroke the unit, meters per second squared. Make sure this high when you label your axis like that, they give you a mark in the GC. After you have labeled your axis, what do? You choose the scale. Where you choose your scale now, you have to partition your boxes, the graph boxes. Choosing the scale is very important. When you choose your scale now, you take points. For example, this is 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, 8. And when you're doing this, when choosing a scale, you always choose scales that are either multiples of 1, multiples of 5, multiples of 10. You can have 0 0.5, 0 0.25. You can have multiples of 10, you have 10, 20, 30. You can have 1, 2, 3, 4, and so on. You can have multiples of 2, can be 2, 4, 6, 8, 10, and so on. So this is the category of what you should choose. So whenever you're plotting any graph, you're opening any graph, please endeavor to ensure that your numbers fall between 1, 2, multiple. It should be multiple of 1, multiples of 5, multiples of 10, and multiples of 2. Don't do any other number, please. It will be difficult for you to plot. And on every graph that you see, you have boxes like this on your graph. If you're working for the GC, Cameroon GC, for example, the number of boxes y-axis is 22 for the graph they'll give you. For the x-axis will be 18. So it depends. So some graph people have 24, some graph people have 18, but the one you have in your exams will be 22 and 18. 22 the y-axis and 18 the x-axis. So we have something like this. So what you need to do is that after you have partitioned, I'm going to choose the next video. I'm going to show you how to choose a scale. When you've done the partition, what you need now is you need to tell you how to get the points. For example, if my first point is 2 and let me see, the first one is 0 0, you put 0, this 0 0. The next one is 1 and 2, so you take 1, this 1, you come up. When you meet 2 from here, you make x. So this is the point. So this point is 1 2. This point is 0 0, which is like the coordinate. The next, let me say, is 3 and 4. You come up. I have my 4. You put an x. We go 5 and let me say 5 and 8. Put another point. All right, you can have the last one, and let me say 6 somewhere. Oh, let me say 7 here. You put another one, x. Now you take a ruler, very straight line. So your line should be very, very straight. Your line should be very straight, and you have to have a ruler. Sorry that I don't have a ruler here to draw it. I have to be very straight. My line will be bent, but your line should not be bent. It should be very fine line, not thick. So you take a ruler and draw a very straight line that passes through most of the points. It must not touch all the points. If there's one point above, there should be another point below. The best line should be the one that passes through most of the points and having equal number of points that are off the line above and below. Then when you have this is a straight line. Don't draw the straight line and start making like this. No, it's a wrong line. Draw one straight line, fine line on the axis, and that will be good. When you have done that, the next thing after drawing a line is looking at the gradient. So how do I get my gradient? The gradient should be as big. You're drawing a triangle from here. When you have 2 points that meet, for example, if I come here, this is another point that comes here and meets here. So this 2 point meets at this point. I'll come and look at another one, not the points you have plotted, not plotted. Take note, not plotted points. So you look at the point, I'll look at the line, it comes here and meets here. I'll look at another one, this one meets, comes here and meets at 2 here. So I'll look at this one too, and I come and I'll draw the another line, meets here. So this triangle like this one is what I'll do for my gradient. So I'll calculate my gradient here. So how do we calculate gradient now? So gradient is equal to change in y over change in x. And how do we go about that? Look at here. So this is the first. So this point here has 2 values. So I said it has 2 values. As a point, you have x value and have y value. This point here also has x value, has y value. This point here has what? X value and has what? Y value. So we can say this man is x1, where is y1, minus x2, and where is y2. So the change in y, we take y2 minus y1. So y2 minus y1, all divided by x2 minus x1. So you have to be very careful. So when you're starting with 2, you should also start here with 2. If you're thinking y2, it should be y2. If you're starting with y1, it should be y1 minus y2 over y1 x1 minus x2. So you should not do something like this. Be careful. If you just do y2 minus y1 over x1 minus x2. This is not correct. You must start with the first. If you're starting with 2, go, but if you get, so this one is same as y1 minus y2 over x1 minus x2. So this 2 is okay. So that if I'm using the false, it's my fault. If my y is false, you'll be having the f2 minus f1 over a2 minus what? A1. That's how you get your gradient. We'll do an example so you see all that if it looks some complex at the moment. So that's how it looks like, right? So when you calculate the gradient, after you calculate the gradient, now the next thing you do is you have to now look at what is the significance of this graph. What is the significance of the gradient? Sorry, we talk about significance of the gradient. What is the significance of the gradient? Not of the graph. I think I mentioned something of the graph before, but I think it's the significance of the gradient. But we ask what is significance? So what do you mean by significance? Significance are asking which quantity, which physical quantity does the gradient represent? That's the question. They ask what is the significance of it. They're asking what is the physical quantity, what physical quantity does the gradient represent? For example, if I have this is force and this is acceleration. If I divide these two quantities, what do I have? You always know by the units. You always divide the units. For example, if I have so you have a what's the unit of force? Is Newton over the unit of acceleration is meters over second. That is it. So if I divide these two units, my result will give you something like, will give me kilogram, which is mass. I'll explain more in the other video when I'm doing an example. So you see that this mass is the significance of this gradient. So the physical quantity this gradient represents is mass. So the answer, whatever answer I have here, if my answer is 2, it will be 2 kilograms. So the gradient will be 2 kilograms. The gradient will be mass. If the answer is 5, it will be 5 kilograms. So my significance of my gradient is what? Is mass. My significance is mass, and the value, your answer to the gradient has to be in the unit of the mass, or kilogram, or whatever unit you're using, or for mass at the time. So that's how you calculate. There's some questions comes which asks you to calculate the gradient, like the area under the curve. We'll do particular problems on that and show you how to calculate the gradient, calculate the area under a curve. Now, so for this video, we're going to end here. But now the next video, we're going to take a sample problem and see how we solve it using these methods that we have done. So to recap, we have said that in order to plot the graph, we need to draw our axis, prepare the data. When you have drawn your axis, what do? You label them. You label them with their units. After that, you choose your scale. When you have chosen your scale, you plot points. After that, you have to draw a straight line. When you draw a straight line, you draw a gradient. Look for your gradient. Now, when you look for your gradient, make sure it's not a plotted point. These points are not plotted points. And I say gradient is change in y over change in x. So that's what you need to do in plotting your points. Yes. And there's one thing I missed out, where you know what is called the intercept. Intercept means that this graph cuts. This is why we call y-intercept. If it cuts this axis, this is what you call x-intercept. X-intercepts asking where does the graph cuts the y-axis, and where does the graph cuts the x-axis. Where it cuts the x-axis is called the x-intercept. Where it cuts the y-axis, we call it the y-intercept. So that's what we go. That's how we do to plot our graphs. So in the next video, we are going to do an example on how to plot using some plotted values, or use some data to plot values. So stay tuned. Thank you so much for being there.